Now that we talk about the maximum and minimum of function, now we want to use the idea of maximum and minimum to solve application regarding optimization. So here we want, for example, if we have a piece of land and we need to fence it, how do we fence it in order to maximize the area of the garden? Right, so we want to maximize or minimize certain things, and that are called the optimization problem. Same with all other application problem. The first thing you need to do is to read the problem until you understand it. You may have to read this more than once. Make note of what is given and what is the unknown. Draw the picture, diagram, and label it accordingly. You then introduce the variable. You write equation that related to the diagram or formulas. Test the critical point and endpoint in the domain of the unknown. So let's take a look at the first problem. An open top box is to make by cutting small square from the corner of a 12 by 12 inches sheet of tin and bend up the side. How large should the square be cut from the corner to maximize the volume of the box? Okay, so let's start with a picture. You have a sheet of tin, and that is the square, the 12 by 12. And then we cut the corner by square. Then we fold up the corner to make an open top box. Okay. So let's talk about the dimension of the square that being cut. Let x be the dimension of the square that being cut. Okay. Then the length of the box now then become 12 minus 2x. Okay. So let's label this. The bottom 12 minus 2x. 12 minus 2x, and because we fold this square up, we cut out the square and fold it up to make the box. The height of the box then will be x. So what do we want to do? We want to, how large should the square be cut from the corner to maximize the volume of the box? So we want to maximize the volume of the box. Start with the formula. What is the volume of the box? The volume of the box equal to the area of the base times the height of the box. The area of the base is 12 minus 2x squared times the height of the box is x. So this is v of x, and we want to maximize. So let's go ahead and take the derivative and to find the maximum of this function. Now note that the domain of this function, what is domain of this function? So because the square being cut from a sheet of tin that is 12 by 12, the value of x is vary between 0 and 12. It's going to be less than 12, right? So note that the domain of this, the domain of v, is between 0 and 12. Excuse me, if you're gonna have to cut both sides of the box, you're gonna have to cut both sides of the tin, then this should be from 0 to 6 instead. Okay, so let's take a look at the derivative. V prime of x equal 2 times 12 minus 2x times 2 times x. This is the product rule and chain rule, so this is a negative 2 plus 12 minus 2x squared. We go ahead and simplify this function to get v prime of x then equal 12x squared minus 96x plus 144. So this is a parabola open upward. Okay, this is the parabola open upward. Okay, so let's take a look. What happened when v prime equal to 0? Let's go find the derivative. V prime. Let's find a critical value. V prime of x equal to 0. That means 12x squared minus 96x plus 144. Factor out 12. This becomes x minus 6 times x minus 2 equal to 0. So x equals 6 or x equals 2. Here we have the critical value at x equals 6 and x equals 2. And let's take a look at what is the v double prime of x. Well, v double prime of x then equal to 24x minus 96. Recall the maximum and minimum that we know, that if f prime of c equal to 0 and f double prime of c is greater than 0, then c is the minimum. If f prime of c equal to 0 and f double prime of c is less than 0, then we have at c we have a max. So let's evaluate v double prime at x equals 6 and at x equals 2. So v double prime of 6 that equal to 24 times 6 minus 96. This is greater than 0. V double prime of 2 equal 24 times 2 minus 96. This is less than 0. This means v of x had maximum at x equal 2. Okay. So then when x equal 2, we have a box of a maximum volume. So therefore, when x equal 2, the box had maximum volume. Let's take a look at the next problem. Find the dimension of a right circular cone, of a right circular cylinder of a maximum volume that can be inscribed in a sphere of radius 10. Okay, so you have a sphere and you inscribe a right cylinder inside the sphere. The sphere have the radius of 10. And we want to maximize, we want to find the dimension of right circular cone. What is it that we need to find? We want to find so here we want to find the dimension of the right circular cylinder, which means we need to find what is R and what is the height of the cone. So here, this distance here, we want to find what is r and what is h. Okay. So let's talk about the volume of that circular cone, of that circular cylinder. The volume of the circular cylinder, the volume is equal to two pi r squared times the height, right? Okay. So here we can't really solve a we don't want to solve a function with two variables, so we will rewrite the function in terms of one variable. So here what I do next is to rewrite it in terms of r. Okay. So if you take a look at this right triangle, at this piece of the cone, excuse me, the cylinder. I don't know why I keep on saying cone. So if this is the right circular cylinder, then the height of that triangle is h over 2. This means here I will have r squared plus 8 over 2 squared equal 10 squared. So that 8 squared over 4 equal 10 squared minus r squared. 8 squared then equal to 400 minus 4r squared. So 8 equal square root of 2 times 100 minus r squared. And I will substitute that into my formulas for the volume. So then the volume is now become 2 pi r squared times 2 square root of 100 minus r squared. Let's clean this up. This is then 4 pi r squared square root of 100 minus r squared. Okay. Next I will find the v prime. Okay. Calculate the first derivative v in terms of r. This then equal 800 pi r minus 12 pi r to the third. Divide square root of 100 minus r squared. V prime of r equal to 0. That implies 800 pi r minus 2 pi r cubed equal to 0. So then r equal to 0, or r equal 10 times root of 2 over 3. Notice that r cannot be equal to 0 here. If r equal to 0, we don't have a cylinder. Okay. I then will make the table of value to test the increasing and decreasing interval of the function in order to figure out where is the maximum value. Okay. So let's take a look at the interval. From 0 to 10 root 2 over 3. From 10 root 2 over 3 to 10. We use the test value. Say r equal 1 and r equal 9 here in this case. And v prime of r has been positive in this interval and negative here. This means the function r v of r is increasing then decreasing, which means here I have a max at r equal 10 root 2 over 3. So then the cylinder is of maximum volume when R is equal to 10 root 2 over 3. Well, H is equal to 2 times root of 100 minus R squared. We substitute this R into this function to find H. In the next problem, a wire B meter long is cut into two pieces. One piece is bent into an equilateral triangle and the other is bent into a circle. If the sum of the area enclosed by each part is the minimum, what is the length of each part? Okay, so here you have a piece of wire and you cut it in two parts. Let the first part be X, then the next part will be B minus X. So let X be the part of the wire that bend into a square. Okay. If I bend that piece of a wire into a square, then the side of each of the square is X over 4. Then the other part, B minus X, is being bent into a circle, which means the circumference is equal to 2 pi R of the circle, then equal B minus X. So R in this case equal to B minus X divided by 2 pi. We want to minimize the area of the two figure, the total of the two figure. We want to minimize the area. So let the sum of the area enclosed, if the sum of the area enclosed by each part is a minimum. Okay, so let's find the area of each part and add them up, and we want to minimize that function. Okay, so the area, the total area, equal the area of a square plus the area of the circle. So A in terms of X equal X over 4 square plus 2 pi R square B minus X over 2 pi square. Simplify this. X squared 1 over 16 times X squared plus 1 over 2 pi times B minus X squared. Let's go ahead and take the first derivative to find the critical value. A prime of X is equal 1/8 X plus 1 over 4 pi times B minus X times -1. So we list these to change to be a -1. Expand this out. So 1/8 X minus B over 4 pi plus X. Here we had 9 over 8x minus b over 4 pi. Okay. A prime of x equal to 0. That implies 9 over 8x minus b over 4 pi equal to 0. So then x equal b over 4 pi multiply a over 9, simplify 2b over 9 pi. Okay. Let's take a look what is the a double prime. or a double prime of x of x. Okay, a double prime of x is n equal to 9/8. Right? This is greater than 0 for all x in the domain. This means at x equal to 2b over 9 pi, a of x is a minimum. So the length of the piece that been cut into the square is 2b over 9 pi. And the length of the piece that been cut into a circle is then b minus 2b over 9 pi. Now we can also use the optimization to find the point on the line. So if we want to find a point on the line that is closest to this origin, first recall what is our distance formula. The distance formula of 2 points x1, y1 and x2, y2, then the distance is equal to distance square equal to y2 minus y1 square plus x2 minus x1 square. So the 2 points in question here, let 0, 0 be the origin. Then the 2 points that we're looking at is x and y, be the point in question. Okay. Then the distance of this 2 points, distance square, then just equal x squared plus y squared. Let's solve for y in terms of x. We start with x over a plus y over b equal 1. So then y equal 1 minus x over a times b. That equal b minus b over a times x. We put y into the function for the distance. So then we get d squared equal to x squared plus b minus b over a square. So let's simplify this. Here we're missing an x. So x squared plus b squared minus 2b squared over ax plus b squared over a squared times x squared. So then we have 1 plus b squared over a squared times x squared minus 2b squared over a times x plus b squared. We can take derivative both sides. So then d 2 times d dx, 2 times d dx, is then equal to 2 times 1 plus b squared over a squared times x minus 2b squared over a. So d dx, or the first derivative, is equal to 1 plus b squared over a times x minus 2b minus b squared over a divided by d, that is the square root of x squared plus b minus b over a x squared. Okay, so then this telling us, well, d prime of x equal to 0 when 1 plus b squared over a squared times x minus b squared over a equal to 0, and we solve for x in this case. Let's clean this up a little bit. Now we want to take a look at the interval of increasing, of decreasing. But what we need to do next, is we will find the second derivative. Okay, we find the second derivative, and then we evaluate the double prime of x at x equal ab squared divided a squared plus b squared. So I will leave this to you to evaluate the derivative and check for yourself to see whether we did or did not get the point that give us the minimum distance to the origin.